And then there's always this what's called a constant of integration.
Yes.
So in your problem, you're going to add 1 to the exponent and divide by the new exponent. And then plus c.
So 10 to the 11th power.
X to the 11th power over 11.
Oh, yeah.
Or
Over 11 plus c. Okay, yeah.
all right, so some students write it as like 1 over 11, x to the 11. You might see that in the back of the book. There's a lot of ways to write it, but that is it. I mean, that is the rule that we're going to be using a lot of, and then we'll do a bunch more here, of course.
Okay.
So the next problem here, 4x to the minus 6. Again, you just add 1 to the exponent. So whatever the exponent is, you add 1 and you divide by the new exponent. This constant just comes with it, just like with derivatives, just comes with it.
Okay. Plus c. So 4x to the negative 5th power all over negative 5, right?
Yeah.
Plus c. Okay.
So the what you will start to do is be able to do this all much quicker, like you are with derivatives.
Yeah.
Because this is not how it be presented. It might be presented this way in some exams or books, but really the other way is that this becomes 1 over x to the 5th. And it becomes minus 4 over 5x to the 5th, like that.
Okay.
So why don't you try number 4 on your own? I know it's not part of your homework assignment, but it might be good for you to try, just one on
Yeah.
your own. I'd actually like to make up a few more that are like this or see what's ahead, because they're not getting some of the ones that
So 9 over 8, or no, negative 6. Isn't a negative 6? We're adding one.
yeah, sorry. I'm
Okay.
yeah.
And then x to the negative 6th plus c.
Yep.
Okay.
All right. I'm looking for a few others. If you're not getting enough of like there's the incrementally like more difficult problems. You're not getting enough of those. 5 and 6 and 7, 8, they transition to another type of. So do you want us to do more like this or just go through the assignment?
Maybe do more just so I get the practice in.
Okay. So here's what I'm seeing. Like here's a typical problem: integral square root of x dx, where um you have to know how to rewrite that as an exponent.
Okay, so x to the 1/2.
Yes.
And then we're going to add 1. So x 3/2 over 3/2.
So it ends up being x to the 3/2 over 3/2 plus c. Then you have to know how to deal with that fraction, which is 2/3 x to the 3/2 power plus c.
Okay.
Okay, so here's another one you might see. Integral of like I don't know, 8 p to the minus 1.2 power dt. So it does not have to be always x. It could be a different variable. It does not
Okay.
have to be an integer exponent.
Um, okay, so I did 8 over 0.2. And then t to the power of negative 0.2.
Negative 0.2, 8 over negative 1, negative 0.2 plus
Plus
c.
c.
Don't get that plus c. And then, I mean, depending on the instructor, you can or can't simplify this. That's up to you.
I don't think we have to, so I think it's okay.
Okay. All right. The only other type problem you might see is something like 1 over the cube, the fifth root of like x cubed. I only put like a 9 here. Would you know how to rewrite this? I mean, this is all about rewrites. It's not really calculus. It's about, do you remember your college algebra, algebra 2, pre-calculus?
So it's gonna be x to the third time to the power of 1/5, and then so it's gonna come to the top. So the integral is gonna end up being 9x to the negative 3/5 power.
Yes. Yep, perfect.
Okay.
So this time when you add 1, you get a positive. And so what you'll sometimes start doing is realizing, well, if I'm going to divide by a fraction, that means I'm multiplying by the reciprocal. And
Yeah.
you'll just start doing that.
Okay.
Okay. So the next ones like 5 and 6 are really good to do, but before we do 5 and 6, we're gonna talk about derivatives. So the derivative of sine of x is cosine of x. Derivative of cosine of x is minus sine x. Derivative of minus sine x is minus cosine x, and the derivative of minus cosine x is back all the
Sine.
way to sine x.
Yep.
So when you're taking derivatives, you go this direction. When you're doing integrals, you're going the other direction.
Okay.
So the answer to number 5, you got to know which way to slide down the list. Basically, one you're sliding down, the other you're sliding up.
Okay. So we would go negative sine x, right, for number 5?
It's just sine x.
Oh.
So because you have cosine x, you're going up to sine x
Okay.
plus c.
X plus c. Okay.
All right, number 6, sine x. Like you find sine x, and you're like, okay, for the integral, I got to slide up, which is really going back down to
Negative cosine.
yes. So
Okay.
this is where it's really hard in this course because you're barely comfortable taking derivatives. Like you're actually pretty good at your derivatives. Now you got to remember integrals, which is going the other way. It just creates confusion. And then you will see problems at some point in the future where you have to do both integrate and differentiate in the same problem. And it's just hard when your brain's got to switch back and
Yeah.
forth.
Okay.
Okay. So 7, 9, a bunch of these other problems are actually not really, and they shouldn't be in this part of the course. They're yeah, there's some things here that aren't really fair to you as a student to know. But if we keep in mind, like, if this were just cosine of x using our list here, what would the antiderivative be? Sorry, guys.
Sine.
Sine x, yeah. So we can maybe say that this is sine 7x, and you're like, okay, I'm going to bring down the 4. Okay, plus a c. You might think, okay, maybe that's the answer, right? Like just I'm going to guess, maybe I'm right.
Yeah.
What is the derivative of this though? Can you just come off to the side here or, on your paper, wherever, tell me the derivative or calculate the derivative of this.
28 sine, oh wait, yeah, 28 sine 7x cosine 7x, right? Oh, cosine 7x.
Okay. See how easy it is? It's like I predicted the future. It's so easy to do this. It's hard. I mean, I probably did it too the first time I learned this stuff. So these are like this is not the same, right?
Yeah.
And that's bad. So what would it take to make it the same? Well, if we divided by 7, which means we divide by 7 there.
Yes.
Now, that's what's hidden from you at this point. Like I'm gonna tell you because you deserve to know, you're a good student. You will learn how to do what's called a u-substitution.
Oh, we did learn that in class today.
Really? Okay. Well, then we're going to use u-substitution. So we're going to do number 8. It's kind
Okay.
of an advanced, it's like if you're just learning integration, you typically don't learn u-substitutions for a while. So I don't
Yeah.
know why you're being taught that, but whatever. I don't make the rules. Okay, so your u-substitution is 9x. What is du in this case? What's the derivative of
Um,
9x?
9.
9 dx. And then you always solve for dx. So you divide by 9. So dx equals du divided by 9. Now you go back to your integral. You do this stuff off to the side. It's kind of like when you're first learning how to take derivatives, you might write f and g and f prime g prime. You always replace whatever you were doing with u. So that becomes sine of u instead of 9x. And then you
Okay.
always replace for dx. That's why you solve for it. Du over 9. And here's what should happen. There should be no more x. No dx's, no x's. Do you agree that there's no more x's?
Mm-hmm.
So
Yeah.
that's thing one. Thing one is that it should resolve itself. Now, it's really 20 over 9. And if I were teaching this, I would want you to take that out of the integral. I'm a first-time student. Thing two is that the integral should get down to one that you know how to do.
Yeah.
That's the whole point of this. Okay. It looks now a lot like number 6. And so the antiderivative of that was minus cosine of u plus c. You're going to bring the 20 over 9 down. When you make a u substitution, you have to back substitute.
So it goes in as 9x, right? Yeah.
Yep.
9x plus c.
And there's your final answer.
Okay.
Now, you don't have to do that. Like, it's kind of like when you take your derivatives, like you eventually just learn how to do them. But as a first time, you really should. Really,
Yeah.
really should. And so the question always is, well, what is the u? And the answer is it depends. So it's often in parentheses. It could be an exponent. It could be what's under the root. What's in
Okay.
the denominator? I don't know. There's others. So the answer is like you do a bunch of problems and you figure out what it typically is.
Mm-hmm.
So here the u is 0.3x. Can you tell me what du is in this case?
Du is 0.3.
0.3 dx. And then you have to solve for dx. So you might write it as a fraction. You might not. Um, so now you go back to the integral and you only substitute in for the u. You have to, whatever the u was, you're gonna definitely substitute for that. And then you always substitute for dx 10 over 3 u. And then it's usually a good step to kind of rewrite it into something that you now can integrate.
Oh, so you move the 10 over 3 over.
Yep, multiply by 5, that's 50 over 3.
0 e u d. And then we just plug in u, right?
Nope, you got to find the antiderivative. This is the only one whose antiderivative is itself.
Uh, e to the u.
Yes, integral of e to the u du is e to the u. So it's e to the u 50 over 3 plus c plus c. And you have to back substitute. U is 0.3x. I don't think the AP does this, but a lot of colleges will they'll actually give you the answer with like as a multiple choice where you don't back substitute in. Really horrible for students because it's a common thing to forget to back substitute.
Yeah.
So you said you did this in class?
Yeah, we did substitutions in class.
Okay. Um, All right, I'm gonna have you start trying some more here. I feel like we're getting into a good flow, but 11 is another like known integral. It's the integral of a to the x dx, which is itself divided by the natural log of the, actually, I think it's b to the x in the books, natural log of the base plus c.
Yeah.
So there's a bunch of these to memorize.
So it would just be 4m over ln of 4, right?
Yes,
Plus
plus
c?
c. Yes. And you can always check. You always like actually take the derivative of this, but you'll find it's not like when you're like learning systems or solving fractional equations or something, like you don't have enough time to check, even though
Yeah.
it maybe sounds good. All right. 13 is a u-substitution. Is there a reason the instructor is telling you not to expand?
Oh, I don't know. I think that's not the instructor. It just was in my book.
Oh, okay. The previous student.
Yeah.
Because normally, like the first time you're learning it, you get a problem like that. You're like, oh, I don't know how to do this. And you're supposed to actually expand. Like that's the, and
Yeah.
then they teach you later on, oh, by the way, you can do a u-substitution.
Yeah,
Um,
we did. We learned u substitution whenever he like gave us a function to like the power of 8.
okay.
We like couldn't expand.
All right. So I'm going to give you the u-substitution. Could you try to work this out as far as you can and let me know
Yeah.
what you come up with?
Um, okay, for dv, I got dv equals du over 4.
Okay.
And then to plug that in, um, I'm finding the derivative of 4v plus 9 to the second power, right?
You're substituting this back in, and it should be like a much simpler integral. It,
Um,
it becomes just a power rule integral.
so 4v plus 9.
But you made a u substitution. Like you've got to you for sure are going to gonna replace that. And then you also
So
replace the dv.
so v is u now, right?
So instead of 4v plus 9, you're putting in u. Instead of dv, it's du over 4.
Oh, okay.
See if you can take it from there, please.
D squared d over 4. Um, is it 2u, 1, or 2u and then times 1/4? Is that right?
No, no, very, very
Okay.
far off here. Remember, so sorry, I'm tired, so I'm not as kind as I should be. You're adding one to the exponent, dividing by the new exponent.
Oh,
That's the power rule. Integral x to the n, add one, divide by the new exponent.
so u3 over 3. Where does the 1/4 comes from the du over 4, right?
Yeah, it just comes down. I think it's better to bring that constant out until you're more proficient at integration.
Okay. And then plus C. And then we plug back in. 1/4 times plus C. Okay.
What number are you supposed to get up to for your homework here?
Um, like 30,
Okay.
31.
All right. So is your final answer 1/12 4v plus 9 cubed plus c?
Yes.
All right. Why don't you try 15 on your own? But before you do, can you tell me what the u substitution is?
8 minus 5x.
You got it. All right.
Okay, I got negative 1/20 times 8 minus 5x to the fourth power
Anything else?
plus c.
You could take a derivative of this. 4 times 1/20 gets you -1/5 times the -5 gets you back to that. So this is correct. Very good. Was that difficult?
Not really, no.
Okay. Is it okay if we do these out of order so that
Yeah.
if we're coming back to so I'd like to do 19 and 21 next. No, sorry, not 19, 21 next. So maybe the first time you see this, like the instructor might say, well, you can write x squared dx plus integral 3x dx minus integral 5 dx, but you don't have to do that. You can just keep applying the same rules that we've been doing. Okay.
Okay.
The only new one that you need here is the integral of a constant, which is like the -5, becomes the constant times x plus c. But the first one is 2 plus 1 over 2 plus 1,
Okay.
3x 1 plus 1 over 1 plus 1 minus 5x plus c. So basically just breaking it apart and then combining it back together if you want. I don't recommend doing this, but they might be teaching that way. I would just go straight to using the rules we talked about.
Okay. Plus c. So x cubed over 3 plus 3x squared 2 minus 5x plus c. Okay.
All right, so might be good for you to try like 22
Okay.
if you want, or we can just keep moving on. It's up to you.
22 is, yeah, let's do 22.
All right, so why don't you work it out as far as you can? It's really similar to what we just did.
Okay. Okay. I got x cubed over 3
Very good.
minus 4x squared over 2.
So that you should simplify.
Oh, okay. 2x squared plus x plus c.
Okay. All right, good. I don't know why that like those problems should have been probably thrown in earlier, but and then 23 is do you have to do 23?
Yes.
Okay, so this one you have to expand.
Okay.
There's no u substitution. What you'll find is if you do u substitution, x's don't cancel out. So I don't know if you want to do that now, but you do have to do this, and then it's a pretty easy integration. Do you want us to do that now?
Yeah, because I actually wouldn't know where to go from there.
So you FOIL x to the fourth plus 5x squared plus 5x squared plus 25. So that becomes x to the fourth plus 10x squared plus 25 times x squared plus 5. And then you have to multiply this out. It's pretty exciting. I know. X to the sixth plus 10x to the fourth plus 25x squared, 5x to the fourth, 50x squared plus 125.
Oh my god.
You did this in a previous course.
Yeah, I know, but I hate doing it.
Even if you don't remember, you still did it. Still did it. So this is what you're integrating.
Okay. Integrate.
We'll see if you can find the antiderivative of that for us. And please simplify the easy stuff. If it divides
Yeah.
evenly, at least do that.
Okay. Okay. I got x to the power 7 over 7 plus 3x to the fifth power plus 25x to the third power plus 125x plus c.
You're good.
Yep.
All right, we'll go back to 17 now.
Okay.
That's the last of the polynomials anyway. All right. So I
I
mentioned
think,
before, like the u-substitutions, like they're kind of a mystery of what they actually are. You make a guess, and if you guess wrong, it makes the problem worse. It's kind of like Indiana Jones with the cup they
yeah.
choose there. Yeah, choose wisely. Uh, so I'm gonna help you choose wisely. That'll save some effort. But when you're doing this on your own, like you should really, that should be your focus. Is like, did I choose the right u substitution and why? Um,
Okay.
so here du is cosine x dx. And one thing you're looking for is the derivative cosine x in the problem? And it is. So that's a good sign that you've done it correctly. If it's not in the problem, that's bad.
Okay.
Yeah.
And then
So then again, you only substitute in for the things that you have. Like that sine x is u, so that goes in there. You don't have anything for cosine x, you just leave it. And then dx is du over cosine x. And this is the first kind of real u substitution problem where there is a cancellation, like the x's have to go away.
okay.
And so you can see how nicely this is. It reduces to power rule integral from something that looked way, way worse when you started.
So it ends up just being sine x to the power of 7 over 7
Anything else?
plus c.
Yes.
Remember plus
You
c.
might see it written this way where the seven's there.
Yeah.
All right, so why don't you try 19 on your own? If you need a hint, I will hint or rewrite it to maybe show what the u substitution should be.
Okay. Use cosine theta, right?
Yes.
Okay. The signs still cancel out even though one's negative, right?
Yeah, it leaves a negative on the bottom, or you can move it to the front.
Okay. So negative u. Oh wait, shoot. Negative cosine theta to the fifth power over 5.
This.
Yes.
Anything else?
plus c.
I've seen teachers like fail students for not putting that in.
Yeah, I think I would get failed if I don't put c. So.
All right. Well, you're doing really well. Do you have questions? I mean, do you have anything you're sort of concerned about here before we move on to like 25?
Not really. I actually think I have a pretty good hang of it. I'm not gonna lie.
I would agree. Yeah. So we'll test that here.
Okay.
What is the U substitution in this problem?
Secant x,
Yeah.
like from the e though, the e
It
secant x.
actually doesn't matter. You're gonna see that it worked out pretty nicely. So yeah, do you want to keep going on this one? You got the right U substitution.
Okay. Ooh. Is it just e to the secant x plus c?
I'll answer. Are you surprised by that?
It just seems a little bit too easy.
Yeah. Well, it does become e to the u du, so it ends up being e to the secant x plus c. You can always try it out. You can always take the derivative of that and see if it works.
Yeah.
Okay, so on that wonderful reference sheet that I sent you, there are all these trig function integrals. We've actually looked at some of them today. It's very
Mm-hmm.
common as a new student to get a problem like the one we're about to get and to not recognize that it's exactly on the reference sheet.
Yeah.
And so that it's like a common test quiz question to get one like, oh, it looks really hard, but it's actually not. It's right there.
Okay. So it's literally just tangent x plus c.
Yes.
Okay.
You might ask how you can show work on Smash. I don't know.
If I don't show work, I'm not going to, and I don't think I have to for my teacher. So
Such
okay,
a
perfect.
it's getting out of control here with the show work thing. All right. All right, number 29.
Okay.
This one is more difficult, but because you have to sort of make a choice. Is your U the tangent or is your U the secant?
My tangent because then it'll cancel out with the secant.
Okay.
So u equals tangent. Okay, so I got tangent to the eighth power over 8. Tangent x to the eighth power over 8 plus c.
Yeah, just be careful how you said that. Like it almost sounded like this, which I know you didn't mean, but
Yeah.
that's different than this. So yeah, that is correct. So I think one more, and let me grab that one. The Sorry for the delay.
It's okay.
Got it right there. All right. So again, be careful here. Which one is it? Is the derivative or is the u cosecant? which it appears, or is it cotangent, which
I'm
maybe you're
pretty
not
sure
sure
it's
of?
cotangent because then it'll cancel out with the cosecant. Is my thought process.
Okay.
Okay.
So you're making u cotangent?
Yes.
Is that what you said? Okay.
Yeah. Cotangent.
Give me some feedback here. You noticing anything?
Um, aren't the cosecants gonna cancel out? Oh wait, can they cancel out? Or
Two of
two of
them,
them cancel? Okay.
two of them do, but not all of them.
So it becomes cosecant
Yeah,
7x.
and there's a negative in there somewhere,
Oh yeah. Negative cosecant
du.
7x.
So this is bad. Yeah, times
Yeah.
u. This is bad. So that means you probably made the wrong substitution. And that's, the more difficult problems, you won't be able to just detect, which one it should be.
Alright.
So let's do it the other way. Let's make it cosecant x. Du is minus cosecant x cotangent x dx. You will find that this works out much, much better.
Alright. And then so integral of u to the 9th power. So what happens to the cosecant in the bottom whenever I work it out? Because
Okay, so you're asking like about that. So you can actually this one's a really, like I said, a little bit more complicated. You can you can put in you can rewrite as cosecant 8 power of 8x cosecant x cotangent x, and then it'll cancel out.
wait, I'm lost.
Okay, so we'll substitute it's u to the 8th,
Yeah.
and then dx is du. So let's leave this cosecant x cotangent x du over minus cosecant x cotangent x.
Oh, you took cosecant out. Okay, that makes a lot more
Yeah,
sense.
yeah. And that's kind of a sneaky one there. They're really working hard
Yeah.
to
Okay. So now it's cosecant to the power of 7x over, oh wait, 9 over
yeah,
9 plus.
becomes just u to the 8th du. So
And then,
that's
oh, but it's negative.
yeah.
Okay. Perfect.
You have the final answer here?
Um, I just did negative cosecant 9 uh plus c.
Okay, good. Is that everything? Is
Yeah.
that everything you wanted to work on today?
Yes.
All right. Would it be okay if we stopped here?
That is perfectly fine with me.
All right. Go ahead and stop the recording.